Morning, everyone. So, they've just left. I was going to start off by just saying a really big thank you to the organising committee and all the volunteers for setting this up. I've been looking at the schedule and I'm blown away. I don't know what track to sit in. I'm going to probably be running between them, much like I imagine quite a few of you as well. So, big thanks for that. And also thank you for letting me come speak. So this is the first time I'm doing this particular talk. So it could be interesting to see what happens. So, how many people have actually heard of Synopsys? Oh, that is impressive. Ooh, excellent. So about 3 years ago, we were at, I think it was InfoSec in London. And people literally had no idea, why is Synopsys there? Who are you? What are you doing here? Oh, thank you. And actually, historically, Synopsys were a hardware company. So what does that mean? Well, if you have an iPhone, an iPad, or any other kind of electronic device, and it has like Bluetooth or USB or anything like that, chances are that the vendor that created this device has either used Synopsys tooling or software to create the designs and schematics and everything, or they've even used some of our IP. We have a bunch of patents in hardware design and implementation. And so that's where most of Synopsys actually sits. There's about 10,000 people in that part of the company. And we're part of the 4,000 other people in the software integrity group. Now, Synopsys started down this software integrity group a few years back, essentially through, acquiring companies. So it started off with a company called Coverity. Many people heard of Coverity? Oh, a couple of people. Excellent. Static analysis tool, really good for C, C++. And then we acquired a few other companies. Codenomicon, fantastic bunch of guys, Finnish, sitting up in Oulu in northern Finland, which I'm pretty sure is about minus 20 degrees at the moment. They came up with they built a tool, which is now called Defensix. It was called something else at the time, but they were the ones who found Heartbleed in TLS. And then 3 years ago, they acquired a company called Digital, which is where I'm from, as well as a few other people in the room. Come see us afterwards. We basically, Digital have been around for about 25 years doing purely software security consulting. So we are consultants, we do lots of software security stuff. We don't have any products per se, but all the other bits that got acquired were products as well. And then Black Duck, which some of you might have heard of. It's basically a tool that you point at source code or you point at a binary, and it can tell you what open source components are in there. And so, are you in trouble licensing-wise, or are you using out-of-date versions and that kind of stuff. So, from a consulting point of view, we do a lot of security activities. We don't just do pen testing, and I'll talk a bit about that in a second. We are down in the gold sponsor area. Do come check us out, speak to us. We're all very nice people. Most of us sponsor me about coffee. This is the obligatory marketing slide. Rory, I'm going to mention Polaris specifically because you've asked me to mention Polaris because it is your favorite part of our product platform. We have a few products, as I said, Coverity, Black Duck, and Defensix, and so on. And we're actually we're building a platform out of them, so we're putting them all together as one unified thing. Other than that, we have a lot of services. So you'll see we've got a bunch of sort of security testing services that we do, which is what me and my team do. And then we also do some more kind of strategic, proactive software security things. If you haven't heard of bSym, go to bSym.com. It's a science experiment that went a bit crazy. We've asked over 200 companies what do they actually do as part of the software security program, and we've built a kind of a statistical model out of what we heard. So anyway, enough of the marketing. Who am I? That's a really big version of my face. So I'm the head of the software security consulting organization for the Nordics and Benelux. In other words, I focus on Scandinavia, Belgium, Netherlands, Luxembourg, that kind of area. Why do I have that region? Well, I grew up in Norway, in Bergen, so I can speak Norwegian in theory. At least that's That's one of those things, never put anything on your CV that you're not willing to back up. When we got acquired by Synopsys, they had a sales team already in the Nordics who, were doing really well. They got lots of customers and they got really excited about services. We were bringing an entirely different kind of thing to the portfolio. So they were like, Nick, you speak Norwegian? Yes, I do. You have to come with us to these meetings. Okay, cool. So I flew over to Norway, and sat in a bunch of customer meetings. And the first customer meeting that I was in where they decided we have to do this in Norwegian, the sales guy did a bit of an intro spiel and then said, and Nick is going to talk about software security. Nick, over to you. And that's the point I remembered that I hadn't spoken Norwegian on a day-to-day basis for 19 years. And also, how do you say static analysis security testing in Norwegian? So that was a fun meeting. I've lived in Seattle in the US for a while. I got hired by a company almost straight out of university, actually, a company called Foundstone, which got acquired by McAfee, which got acquired by Intel. And I did a bunch of security testing for them. I was over there for 5 years where I met my lovely wife. And now we're in London. I've been a consultant for about 14 years. I started off in penetration testing, loved it, had so much fun, broke a bunch of stuff, learned a lot. And then, having done that for a few years, moved back to London, still as part of McAfee, to help them build a consulting business in Europe. And I sort of got dragged into incident response a bunch. So we had a lot of customers, McAfee customers who kept getting hacked. That's not a comment on the product, it's just, people get hacked. And so we would sort of get parachuted in, and I was just meant to be a project manager, and all of a sudden I was on a plane on 10 hours notice to wonderful countries in the Middle East, saying, hi, honey, I'm off to a country in the Middle East. I don't actually know when I'm coming back. 4 weeks later, was my record. So it wasn't my favorite activity, but it was really exciting, really interesting, and I learned a lot. Done a bunch of training, and then when I got hired by Digital about 5 years ago, I got really into software security, and that's where I've sort of loved being ever since. Got a bachelor's in computer science from Exeter University, and I've got a master's in information security from Royal Holloway. Anyone heard of that program? Anyone been to that program? Ooh, no, okay. One thing they don't have is this, which is fantastic. If they could organize a conference, then, they couldn't put this on. So, kudos to you guys. There's my email address. If you want to follow me on Twitter, I usually just rant about cycling, but sometimes I post about security. So let's first talk a bit about history. So I'm going to sort of talk a bit about software development and security and how, for a very long time now, they've sort of not been very good friends. They haven't played well together. And so I'm going to talk a bit about what's happened, what's happening, and what I'm sort of seeing, what we're seeing kind of happening with a lot of our customers. And sort of, I've got some, I call them career suggestions, but in other words, they're more like humble requests to come join us, in helping companies develop better software. So in the beginning, this is kind of how software development happens. It's a really boring slide. It's meant to be. Whichever kind of development process you follow, there's usually these kind of five steps, maybe a couple of extra depending. So you've got your requirements analysis. You build a big list of everything you want the software to do. And then once you've got that, you go into design mode and you design the software to figure out, okay, to make it do all those things, we need it to look like this. Then you write the code. And then you test the code. And then, in theory, everything works, so you ship it. Now, what I've just described is essentially the old classic waterfall model. It's very linear. You do all your requirements analysis, and you draw a line under it. And then you go, right, now we're working on design. And you cannot change the requirements, in theory, but you have to. And then you finalize your design, you draw a line under it, and then you start implementing. And you can't change the design, in theory, but you have to. Because you're about halfway through writing the software, and you realize, oh, we forgot about the requirement about usually security or something. So now we've got to go back to requirements analysis. Well, how do you do that in a linear process? It's really expensive, it's really hard, and so waterfall wasn't the best kind of model for this, at least from a security point of view. So there are more modern ways of approaching this. In fact, pretty much nobody uses pure waterfall these days when they do software development. There's usually some Agile, some Scrum, some CI/CD, some DevOps, and wonderful things. So they basically all have the same components, but they happen in a different way. So, a sprint is usually a 2-week sprint or something like that. And so you can't do all of this. You can't build an entire app in 2 weeks. Well, you could try. But what you do is you pick a few requirements, a few user stories, and you try and implement that in 2 weeks. And then the next 2 weeks you try some others. So there's different ways of doing iterating these things, but fundamentally you're dealing with the same kind of activities. Fixing problems kind of expensive, still is. So something happened in the 90s. Has everyone read Smashing the Stack for Fun and Profit? Yeah, excellent. Okay, if you haven't read it, go ahead and read a bit. It is from 96, I seem to remember, so it's a bit outdated, but the concepts are really well explained, really straightforward. It was written by this guy called Aleph1 or Eli Levy, basically he's describing, in a C program, you've got memory space, and the developers expect you to only put stuff into that memory space that's going to fit in there. What if I put more in? What if I try and put more into that memory space than the developer expected? Well, things happen. Fun things happen. So the developers kind of had this inherent assumption that people and systems, etc., will use my software or my system the way I intended it to be used. And it turns out you had hackers, crackers, freakers, the RAND Corporation, military. They all thought a little bit differently. They thought, no, what can I make the software do or the system do that it wasn't intended to do? How can I break it? Or how can I use it for other things than what the developer expected? Now, this didn't come out in the 90s, like hacking, penetration testing. Actually, penetration testing started its life in the 1960s. But something else changed in the 90s. Stuff like FRAC got published. And also, the internet happened. So pre-95-ish, not a lot of people on the internet. I was on the dial-up modem. I see some grey hair in the audience. You remember dial-up modems. So a few things happened. The internet became a really democratizing force, not just for your consumers, but also for your hackers and people who wanted to kind of mess with systems. So you had more people messing with more systems. So you had more attackers. You had more attacks happening, and you had a bigger attack surface. You had a lot of systems that were never designed to speak to the outside world, speaking to the outside world via the internet. So there was a lot of kind of new challenges for developers. The problem with the developers was they typically had less money, they would go shorter timelines, and to a certain extent they were lacking key skills as well, especially within security. So you've got this dichotomy of lots more people looking at your systems, and you've got less time to secure them. So you've got this race between the makers and the breakers. The developers, they're trying to cope with a scary new world, and you've got hackers, penetration testers, etc. Developing new capabilities, new tools, new attack methodologies or methods, new sort of pen testing methodologies. We even have degrees now. People have to take us seriously. IT security, traditionally very network, very infrastructure oriented. So their response was very much along the lines of, it's okay, we've got a firewall. It's fine. Nothing bad will happen. So a good example of that was, back when I was doing incident response, I got dragged into one case where a company clearly bleeding. They've got people on the inside of the network, and so first thing we did was we stopped the bleeding. We figured out how to plug the holes. What happened? Let's look at your firewall logs, your intrusion detection logs, and so on. And they said, our intrusion detection logs, they've got this alert. This thing keeps yelling at us about this thing, but it must be a false positive. It can't possibly be real. It's like, well, why can't it be real? Well, because the signatures in the intrusion detection system, the rules, they were written at some point, and the rule will be timestamped when it was written. And this particular rule that was in their system was written 10 years ago, so it can't possibly be real because they are really up to date on all their Windows patches. So, really old rule triggering, it must be a false positive. And so, which rule is this? It's called SQL injection. Right, okay, so someone's been hammering your front-end website with SQL injection, your intrusion detection system has been yelling at you, but you thought it was a false positive. Yeah. Okay, turns out it wasn't a false positive, and there was a fair amount of cleanup. Now, these guys were really good at their jobs. They were network operations center people. They were very good at maintaining a secure network and patching systems, but they didn't really know much about application security, so they didn't know what SQL injection was. So, it's fine, we have a firewall. It's not fine. Meanwhile, sort of early 2000s, a few things happened around kind of software security became a thing. So, Bill Gates at Microsoft puts out a memo, I think, every year, or used to put out a memo every year. 1 year was about the internet, or the tidal wave, I think it was called. And then 1 year, in 2002, it was trustworthy computing. Not a term that you hear very much these days, but at the time, it was the new thing for Microsoft. And they also put out this thing called the Secure Development Lifecycle. They published a book. And it's basically how Microsoft wanted to do software development with security baked in. And to a certain extent, they did that for some things. And lots of other companies read the book, thought, oh, this is brilliant. There are some really good ideas in here. Let's use it. At the same time, some clever guys at a company called Digital published a book called Software Security. Ooh, hello. And in there, the authors, Gary McCraw, Sammy Miguez, and John Stevens, and a few others. Paco, did you? Yeah, Paco put some content in this as well. If you haven't met Paco used to be at Digital. Have a chat with him at some point. He left us, the traitor. He's now at AWS, but he's doing fantastic work there as well. Anyway, so we put in sort of the concept of these touch points. In software development, you have these activities. Well, for each of these kind of stages, requirements analysis, design, etc., there's security things we can do for each of them. So let's come up with these touch points where we talk about for each of these stages what to do. OWASP became a thing around about then as well, and has now turned into a really quite fantastic organization with pumping out lots of really good material. If you're into, they're not just web stuff now. They've got mobile stuff, etc. And their content for both, if you're doing security testing, how to do it, really good. If you're a developer, what's the problem with, SQL injection, cross-site scripting, and so on. They've got some really good material there as well. Okay, so we had some few different ideas, excuse me, about how to introduce security into software development. What did that look like? Well, everyone started with penetration testing because everyone knew what it was. It was a predictable thing. So we've got a bunch of applications. They're out live in the great big world. What can we do to them? Well, we can do a penetration test. Okay, let's go pen test our systems, our applications. Wow, that is a lot of bugs. Well, I guess we add those to the backlog. So we had a pile of security issues that we ended up with. But the problem was that these applications were already live. They're already in production. That's a bad thing. We know that there are holes, and so how do we fix them? So, okay, how can we make sure that we find these bugs before it goes into production? Well, let's do penetration testing before it goes into production. That'll fix it. In a lot of organizations, what ended up happening was you do penetration testing about 2 weeks before you're meant to go into production. The thing is, the penetration test takes a week or 2 weeks, all depending. You find some problems, and then the developer fixes them magically overnight, right? Just before release. That's going to happen? Yeah, cool. That didn't really happen. So what you ended up with was a bigger bug pile. You knew you had, but you were still going to go into production because you had to risk assess and go, well, we can't stop the release. So bigger pile, still doing pen testing. Okay, well, how can we do things earlier? Well, let's do code review. So let's look at the actual source code and see if we can identify security bugs. Cool. This is really boring to do manually, so people invented tools. One of the first tools out there for security was called ITS4. which was developed by these smart guys at Digital a while back. It was kind of a proof of concept, and if I know my history correctly, basically it was kind of a case of, well, we're not going to do much with it, but it's a really cool concept. Let's give it to some venture capitalists, and they'll turn it into something. And they turned it into this thing called Fortify, which became quite big. And I'm sure someone in our company was kicking themselves a bit for, letting someone else run with it, because we probably could have, made it quite a big success as well. But yeah, lots of tools out there looking for bugs in your source code. But we're adding to the bug pile. We're still not addressing, okay, well, when are we going to fix it and how are we going to stop increasing the bug pile? So this is kind of what maybe some organizations would consider sort of a secure software development lifecycle. You're doing a bunch of different things throughout the lifecycle. So when you're doing requirements analysis, you make sure that you come up with your security requirements. You come up with abuse cases or attack stories or whatever you want to call them, and you do some sort of risk analysis. We know, okay, well, these this application is going to talk to the internet and it's going to be handling credit card data. Okay, well, that involves certain risks, so let's address those early. So let's come up with some requirements that try and mitigate those risks. Then when we're doing architecture and design, we do threat modeling. Many people do threat modeling? Ooh, okay, so excellent. Fantastic. So, you essentially, you look at the design of the application and you say, great. Now, as an attacker, I want to get to the crown jewels within the system. How can I get to them from a design perspective? Are there security controls missing, or are there security controls that aren't up to scratch? Can I get around them somehow? And then we do risk analysis on what we find, so we make sure we prioritize what we need to implement early. Talk about code review. Again, we do penetration testing. That's kind of just a given. And then once we're in production, we'll have some sort of security operations center, making sure that the application stays, isn't under attack. And then bug bounties fit in somewhere here. That's an entirely different talk. Although I do feel like I should mention one thing. So we organize a conference every year for all the companies that are in BSIM, the Building Security in Maturity model that I mentioned earlier. And we had someone come and give a talk one year about bug bounties. And it was really interesting to see basically half the room thought bug bounties were the coolest thing ever. And the other part of the room thought it was the dumbest idea ever. And the truth is probably somewhere in the middle. Okay, so hacking is fun. Penetration testing is really good fun. Breaking stuff is fun. I certainly enjoyed doing it. One of my earliest pen tests, I actually I discovered that they had a cookie, and there seemed to be some encrypted data in the cookie. And I ended up because I was fairly fresh out of my master's course, I was like, I'm going to cryptoanalyze this. So I did some, statistical analysis, I did some differential analysis on it, and I figured out, it's that super crypto algorithm called Caesar shift. With some bells and whistles thrown onto it. And so basically I sat there with a pen and paper and cracked this encryption code in about half an hour. And I loved it. It was so much fun, especially explaining it to the developers, this is what I did. And they were just blown away by, how could you do that? Well, I have a degree. So really good fun. And it's rewarding as well. I mean, anyone here do internal network pen testing? Yeah? First time I got domain admin, that was such an adrenaline rush. It was so fun. It was my first ever internal pen test. It was really embarrassing because in Foundstone we basically had kind of an unofficial leaderboard with regards to how quickly from plugging in to getting domain admin can you get. And I think the record at the time was my boss, Carrick Dooley, and I think he did it in something like 18 minutes. Plug in, domain admin, and then, what do you do the rest of the week? First internal pen test, I'm plugged in, I'm like, I need to get domain admin, and it took me a slightly embarrassingly long time to do it. Had my boss on Skype messaging me like every 20 minutes going, dude, why haven't you got domain admin yet? So I finally got it. It felt so good. I felt really sort of personally rewarded for it. And breaking stuff is useful as well. I mean, we're shining a light on issues where the developers had never expected us to try and do this to their system, and how else were they going to find it? Slight problem. Breaking stuff does not magically fix the stuff. That's still something we have to do. And this can cause some animosity. So if you're the security guy and you're talking to the developers, and you're breaking their stuff, sometimes this will come across as you walking into a room and going, "Hey, developers, your baby is ugly," and then walking away. So, depending on the organization, this isn't going to go well sometimes. In fact, one company I was at, first day on site, doing a web app pen test, I had to go on site to do it. Security guy takes me down the hallway, walks me into this room full of developers, in fact, the developers for the system, and he says, "Hey guys, this is Nick. He's here to break your stuff." How much help did I get from those developers that week? None. Actual quote. We kind of talk a bit about, at Synopsys, we talk about penetration testing kind of being a badnessometer, in the sense it is really useful. But let's say you have a pen tester go in and spend 5 days, and he comes back and he gives you a report saying, "I found these 4 problems." What do we know about the application that he's tested? I was going to say it more politely, but yes. F all. We know there are at least 4 issues. What if the pen tester comes back and says, "I didn't find anything"? Is it a secure system? Nope. We don't know, essentially. So, yeah, it's, we don't know, and we know we have some problems. So Dijkstra, back in the 60s, said this about testing, software testing. We can use testing to show the presence of bugs, but we can't prove the absence of them. I thought I'd talk a bit about DevOps, because it's the new sexy thing. Actually, it's last year's thing, isn't it, at this point? Also, big shout out to the marketing department at Synopsys. I gave them a really bland set of slides, and they went crazy on Shutterstock. There's some really cool stuff in it. I actually had to tone it down slightly because So DevOps, what is it? Let's talk a bit about terminology. Now, people have different definitions of this stuff. So these are our kind of definitions. Your mileage may vary, but essentially, Agile, it's all about processes. So Agile processes is kind of an umbrella term for different kind of development processes. Typically, you're focusing on changing, making changes to the functionality of the application and so on. You're trying to optimize delivery. So you're trying to figure out how can we, in an agile manner, make a change to the software quickly. And then we have this thing called continuous integration or continuous delivery or continuous deployment. CI/CD. Now that's more kind of tool focused. It's basically how can we define software development life cycles using software. So we have a software defined life cycle, essentially. Things like Bamboo, Circle CI, Jenkins, these kind of tools fit in here. The idea is if there's a task, let's say compiling the app, that we can do without having to manually type something out, let's find a way of doing it automatically. And that's what build pipelines are for, etc. And if we can test the app in some automated fashion, let's do that as part of our Jenkins pipeline as well. The focus here is on automation. And then this DevOps thing. So DevOps, development and operations. Historically, development were over there, operations were over there, and security was somewhere at the back yelling just inane things. And none of them would talk together. So if I was a developer, I was not allowed to touch anything in operations in production. If I wanted to make a change to production, I had to go to an operations team and probably open a ticket and beg them, pretty please, can you make this change for me? And so the roles were very split off. The idea behind DevOps is you have one team where development, operations, everything is in one. And so you're redefining the roles, you're redefining the culture in the organization, and making it more responsive. So you've got one team that is responsible for the software all the way through development and in production. So, the code I push out in production is my code, and I'm responsible for what happens when it goes into production. I have to respond. Or we as a team have to respond. So this is what software developers are doing. They've kind of gone down the DevOps route. Some of them are very comfortably in the kind of the agile space. Some of them are trying DevOps. Some of them have gone full DevOps. A lot of people are somewhere in the middle. And security kind of sitting in the back going, what's DevOps? Especially more traditional security teams. So, if you think back to like the waterfall approach, the linear approach was really comfortable for security because you do your requirements analysis and then security can come in and go, we're going to add a couple of security requirements and cool, we've signed off on the requirements. And then the same thing happens to design. So, the developers and the architects, they draw a nice design and say, this is what it's going to look like. And the security guys come in and go, yeah, okay. We anoint this, we accept it, and so on. And all these activities were taking weeks. So a code review would take a couple of weeks, a pen test would take a couple of weeks, and so on. A threat model would take a couple of weeks. Can't really do that in an environment where your sprint is 2 weeks long. In that 2 weeks, we need to figure out which features to implement, how to implement them from a design point, actually implement them, do testing of it, and then ship it. We don't have time to spend 2 weeks on requirements analysis, 2 weeks on threat modeling, 2 weeks on code review, etc. So security teams have to kind of refocus and think about, okay, what are we trying to accomplish? Not how can we speed up the same old activities, because the wheels are going to come off. So developers use things like Jenkins. We could use things like Jenkins. In fact, we have started using things like Jenkins. This is just an example of the pipeline. I built it myself. Thank you. The trick is to make all your Jenkins stages empty, so nothing happens. And that way you get a green check mark for everything. So it succeeded. So this is running on my home Jenkins server doing nothing. It's just there for making a screenshot. So this is an example kind of what we might do for some of our for some of our customers. We'll go in and go, what security tools do you have? What are you trying to achieve? What does your build pipeline look like? Okay, well, let's see if we can insert some security stuff in there. So in this case, we put in some static analysis for security. We put in some dynamic testing and so on. So, from a security point of view, it's great that we're breaking stuff, but the developers aren't going to love us for breaking their stuff. They're going to love us for telling them and helping them fix the stuff and prevent it from happening in the future. And so, from that perspective, if we're not speaking the language of development, if we're not using the same tools, the same processes that align with their kind of worldview, we're not really doing software security. So where does this lead me? I wasn't sure how to title this slide. I started off with some career advice, but that sounded a bit arrogant. So I've gone with career suggestions, but also consider this to be some humble requests from someone who is constantly trying to hire people who know about software security. If you don't know how to program, learn it. You don't have to be like a fantastically talented software developer, but you don't have to know every language. You don't have to know a specific language. Pick something up. I think we probably in our office in London on a semi-weekly basis we have like a religious war brewing because Matthew is very much the Python guy. Amanveer is very much the JavaScript guy. And then someone will run into the room and go, Golang! And run out. And chaos ensues. So yeah, it doesn't have to be a specific language, but learn some of the concepts, like functional programming, Lambda functions, object-oriented stuff. This is really useful when you're talking to the developers. So when you've sort of given them your pen test report and said, your baby, I'm not going to call it ugly, but it's got some issues, then you're going to have a much more fruitful and constructive conversation with the developers if you can speak their language, if you can relate to them, with the concept of, okay, what frameworks are you using? Well, in that framework, if you use this function, it's better than if you use this function, for example. And one way you might do this is find a pet project. I've always wanted to do, a bit of PHP programming. Okay, write yourself a little website or something, or in Python. I'm sorry, Matthew. I'm sorry. So yeah, you can blog about it. Put it on Git, put it on Bitbucket or whatever. Or if you don't want to start something from scratch, there's plenty of open source projects out there that, especially within the security space, that could do with some help. So start contributing. I don't know why I keep using the clicker. It's clearly not working. Another thing is learn architecture, software architecture, I mean. So learn things like, okay, what do the various frameworks do? What does Java Spring do? What does Rails do? And so on. And how can they help the developers? As I said, a lot of the time when we're having conversations with developers about, I found some problems, then a lot of times it can come down to, look, if you use the framework like this, you're going to avoid these problems. So if you learn how they work, you can be helpful. Become fluent in things like end-tier application architecture and other fun phrases, which architects will use to bamboozle you. I had one conversation once where with an architect where he came into the room and said, look, we don't have any requirements for the software. We have principles. So we talked a bit about it, and it turns out they were requirements. They just didn't want to call them requirements. So this becomes super helpful when you start doing threat modeling, for example. You need to be able to understand design language, design diagrams. You need to be able to even draw them as well. Visio will become your friend, sort of. And also, not every security issue is a bug. Some of them are design flaws. So what do I mean by that? Well, the way we talk about bugs and flaws is bugs are mistakes that you make in the code. So you forget a semicolon, or you indent your Python wrong, or, sorry Matthew, it's like my biggest problem with Python. Or, you meant to take one variable and add it to another, but you actually subtract it, or something like that. Your intention was correct, but you fat-fingered something. That's a bug. A design flaw is where, when you designed the application, you forgot about something, or didn't quite design it right, so maybe you forgot to put in authentication. That's a pretty big forgetting something, but it does happen. Or you think you've designed like an authorization scheme that will protect all the crown jewels, but actually you left a great big gaping hole over here on the left or something. And so here's an example of a design flaw. This is my cat Alex. Alex is a dick. He's not really, he's just really affectionate. And when he doesn't get affection from me or my wife, he turns to his friend, the Roomba. Now, the way I discovered this was basically I'd come home from work and there's a Roomba in the corner with a dead battery. And it kept happening. And then one day I was working from home and Alex is asleep on the bed in the bedroom and I hear the Roomba go doo-doo-doo. it's going to start its thing. And Alex gets off the bed and runs downstairs. I'm like, what is happening? Alex has figured out that to get affection, he just has to wait for the Roomba to wake up. And he gets pets. So this is what I call a design flaw, because the makers of Roomba have done lots of really clever things. But one thing they never planned for was what I call the attention-seeking cat abuse case. So he has finally stopped doing this. But we had to buy a new battery for the Roomba. Excuse me. Okay, crypto. Oh, crypto's scary. Crypto's hard. Crypto gives me a headache. But it is worth knowing a bit about it, getting familiar with it. Some of the history of it. You don't have to become a math whiz, but knowing why it's hard to get right is really handy, because there's some classic mistakes that have been made. Have you heard of Needham-Schroeder? I picked a really obscure example. I want to thank Professor Kenny Patterson at Royal Holloway for this one, because he made us all learn this as part of our network security class. Needham and Schroeder, clever people, they came up with two authentication protocols back in 1978. One was secret key-based, one was public key-based. And it only took about 3 years for someone to break the secret key-based one. In fact, there's a replay attack in it. But the public key one actually was fine for about 17 years until someone figured out, actually there's a man in the middle attack in this thing. So, really smart people coming up with what looks like a really clever idea, and it seems really clever, and then 17 years later someone goes, actually, here's a really simple way of attacking it. So, it's really hard to get right. And there's a similar story for things like RC4, MD5, and quite a few other algorithms and protocols out there. So I'm not looking for anyone to start inventing crypto. I'm looking for sort of, if people can get their heads around why smart people do dumb things. That's a bit of a harsh way of putting it, but why these things can happen. You don't need to be a crypto expert. I think this goes without saying, especially given looking at the schedule of the next day. It's not just about web apps. Although I think we probably spend about half of the testing work that we do, if not more, is web apps. We do a lot of mobile testing as well, but about half of all the work that we do is probably web apps. But we do a lot more of our interesting work in things like Internet of Things, automotive, medical devices, that kind of stuff. Mainly, and it's sort of in rich pickings, in the sense that a lot of these technologies are being built without necessarily security being a main player in the beginning. So we're kind of seeing a repeat of the mistakes made in previous generations of technology. And this is where you can bring a lot of value by both demonstrating the issues with the technology, but if you can speak authoritatively about how to avoid the issues and how to fix the issues, you'll become someone's best friend. Embrace everything as code. I feel like I should mention AWS at this point. AWS have very much gone down the road of everything is code. Our infrastructure is code. Our network is code. Our policy is code. Who's going to read a Word document? Nobody. Who's going to make their code pass a bunch of security requirements that are built into the build process? Everyone, because they don't want to have to deal with the friction. Build pipelines are all code now, Jenkins, etc. Security tests, we can write them as code now. So if it's Jenkins pipeline or if a Metasploit script or anything, it's all code, and we all end up sticking stuff in Git now. I'm sure there are other examples I've forgotten here. Consider being a security champion within the organization where you work, or at some point will work if you're studying. So as I said, you've kind of got these camps. You've got security, you've got development and operations and so on. One thing that we found is it tends to be a lot easier to teach a developer about security than it is to try and teach a kind of a more traditional IT security person about how to speak to developers. There's sort of, it just seems to work better the other way around. So, in a lot of organizations where we work, the software security group is able to be relatively small because they've got these champions in the engineering and development teams who, they're developers or they're architects and so on. But they have a passion for security, they know about security, and they become sort of the focal point within their team for security. So the software security group doesn't have to run around and yell at everyone. There's people actually embedded in the organization. So they're kind of a sweet spot. And don't forget about culture. So different organizations have different cultures. So you've got kind of the developers and the security, they're kind of an us and them in a lot of organizations. And depending on the corporate culture, that can be really brutal, us and them. In other organizations, a little bit more collaborative. So if you're a consultant on site at an organization where they've got a very sort of us versus them culture, you're going to have to work harder to win over the developers. And so be conscious of that. So, technologies keep changing, but, the peopleware, we all kind of, stay the same in the sense that, we all have our hang-ups and, we all have our cultural kind of, paradigms. So, sort of in summary, finding security, issues is the easy part. Doesn't mean, it's just easy. It's really hard. It's really challenging, and I've spent I don't know how long staring at one particular system where I'm pretty damn sure there's a hole. I think I can get through it. I just waste 5 days trying to figure it out. It can be really hard and really challenging, but relatively speaking, it's the easy part. Because once I found an issue, the developers then have to go fix it. They have to figure out, okay, well, how can I fix this in such a way that nobody can do that particular attack and anything that looks a bit like it? Has anyone done a pen test where they found a cross-site scripting issue, and in the report they say, okay, steps to reproduce, go to this page, put in this into the input field, this particular value into the input field, and click go, and voila, you have a reflected cross-site scripting attack. And then the developers fix it by blacklisting just that example. Happens quite a lot. So developers aren't used to this kind of approach. They're not thinking about, well, how do I need to escape values and treat it across trust boundaries, and how do I do encoding, etc. They're thinking that is an attack. I need to stop that. So it's hard to get things right. And then ultimately, preventing these issues from happening in the first place, that's the biggest challenge of all, and where organizations will spend literally millions trying to solve this problem. So be conscious of that magnitude. By the way, we're hiring. Our lovely lot, who someone at the back, will be at the stand all day, as will I. So please do come have a chat if you'd be interested in working with us. We have consulting positions open. We're looking for interns this summer as well. So I have to admit, I'm trying to think, how many Abertay alumni do we have in the office right now? It's something like 5 or 6. And quite a few of them came through kind of the intern program. So we brought them in over the summer between the second and third year, had lots of fun, and then we ended up hiring them. So please do come talk to us if you're interested. You'll find some friendly Abertay alumni, and then you'll find some other people. We try to be nice as well. And with that, thank you very much.